Okay, so we are now going to demo intersections. All right, so we've talked about how these work, that they can be very useful in identifying overlaps in our vector data. Okay, and so let's see what that means on a practical level, both the kinds of questions we would be answering when we use intersect and just how we implement it in ArcMap. Okay, so let's work with this data that I have here. So lots going on. Let's take it layer by layer. So the first layer we have is a layer of all the fields in southern Ontario that are in annual crops. So these are all fields growing things like corn, soybeans, so on and so forth. And for reference, I don't have this context on the map, but for reference, this is KW. This here is Guelph, Cambridge, so on and so forth. Okay, just to give you a sense of where we are. Let's look at this attribute table. Okay, lots of information. The key thing here is cover type. So it's all the same cover, annual crops. All right, the next piece of information we have is soil type. Okay, just for a limited area here. Okay, but this dark brown red color indicates soils that are particularly healthy and suited to agriculture, and especially crops, annual crops. This kind of light brown color are soils that are actually not all that suited for agriculture. So we want to know, are there places where farmers are growing annual crops, which are very intensive, can be very intensive on soils? Are there places where farmers are growing these soil-intensive crops that are actually on poor soils, soils that aren't suited for agriculture? Okay, we would ask that question because maybe we want to encourage these farmers to be implementing other kinds of agriculture on these not so great soils. So we need to find the intersection of annual crop production and unsuitable soils. So let's bring all this data back on. Before we do, let's look at the attribute table. Okay, lots here. Key thing that we'll come back to is this field here. It's got a wonky name. I happen to know that the 1 is best suited and the 6 is least suited to agriculture. Okay, so that's how we measure that or store that in our attribute table. All right, bring the annual crop layer back on, and we can already kind of tell just visually where there are fields of annual crops on poor soils. But we actually want to create a new data set, perhaps one that we can share with other people, explicitly and only identifying the locations of these fields of annual crops on poorly suited soils. So again, we will go to our geoprocessing menu and we will choose Intersect. Now we are inputting both of these layers, annual crop and the soil layer. Okay. There are some other options here. I encourage you to explore them. For our purposes, we can leave the defaults. Okay, we're just interested in a general sense of how Intersect works. So let's let that run. So again, it's going to pop up down here and run. And you can see that we end up with a new layer. So let's turn off all of our previous layers and just focus on this new one that was created. It looks like a lot of different shapes. Let's figure out how we symbolize this. We will go to the Symbolization menu. In this case, we have unique categories across many fields. All right, and to make that point clear, let's actually start in the attribute table. Now we just learned that with an intersection, we retain the attribute tables for both of our layers, okay? Or all the layers in our intersection, all the layers we are intersecting. So we can still see here, we still have that cover type field. We also still have that good bad soil field. Remember, 6 is bad soil, 1 is good soil. So we need to combine these in our symbolization. And we have that ability. We'll go back to that menu. Again, we were talking about categories here, categories of data. We'll go to unique values, many fields. We're going to choose 2 fields. One, the cover type, okay? That is just annual cover. But you can imagine if we had more different kinds of covers here that we wanted to explore the intersections of, we could. Okay, and we will also choose the field representing the soil quality. We'll add all those values, and you can see we have the intersection of these two. So 121, that's the code we use to represent the annual crop cover type, and 6, bad soil. So you can see that we are going to shade the places where those two things intersect, that color. And then on here, where we have the annual crops on good quality soil, we're going to color them that. And we can see a little bit about the count, the number of shapes in each. Okay, so we know that generally, there are going to be more places where, farmers are growing crops, annual crops on good soil. Let's just, style this a bit so that we can make it clearly seen. So we'll just turn this into a kind of red color so that it really pops out, and we'll just leave that color as it is, a kind of background color. Obviously, you would want to think more closely about the design. For our purposes, this is fine, because it just helps us see where these things are. So we know that the tan color here represents where farmers are growing annual crops on the best soil rated as number 1. And this red indicates those areas produced as a result of our intersection analysis, where soils are growing annual crops, soil-intensive crops like corn, on soil not so suited for agriculture, level 6 soil. Now, the reason why this whole window isn't filled with soils types is just because we're only using soil type 1 and 6, best and worst soil qualities. Okay, we could have used all the different levels or numbers representing soil quality, but we just chose 1 and 6 because we just wanted to figure out where are the best and worst. Okay, but now we have an explicit representation of those farm fields shown here in red, where the cover type is annual crop and the soil is not so suited to those kinds of crops. So that is a practical example of how to use intersection on vector data.